Do all of you have a paper in front of you? Yes? Pencils? Okay. You're going to be working with a partner. You're going to be correcting yesterday's exit ticket. Okay? Work on this one. You two work on this one. You two ladies, work on this one. You two gentlemen, work on this one. Okay, when the timer goes off, we'll ask a group to come over and explain to us their process. Okay, so just check to see if that's correct. How can you check?
Wait, is this right? Yeah, it's right?
Explain to me how you would start. You see some word there.
But it's right though.
It's right? Okay, explain to me the process. How do you know it's right?
Because they added 4 plus 1, then we got 5, and then there's no more steps. You can't divide 5 except the y, so then it leaves it by itself. And then
Okay, and then what's a negative 1? Okay. Ladies and gentlemen, we're going to have somebody come up here and explain the process to us. Everyone else, see if their process matches your process, okay? Or if you did something different than what they did, okay? Let's give Alicia a round of applause. All right.
for sure.
I multiplied the top equation by -1 to make 3 over 2x positive, so that way I could cancel out the x's, I guess. And then I subtracted -1y and 2y, and I got y. And then you add together 4 and 1 at the end, and you get 5. So y is 5.
Good job. Okay, thank you, Alicia. Let's give her a round of applause. Ladies and gentlemen, I'm going to come around and pick up your work. This is what we are doing today. We're going to talk about our essential question for the lesson and our enduring understanding. So for today's lesson, what you need to be thinking about while you do your work, what are the advantages of solving a system of linear equations graphically versus algebraically? Okay, have that in mind. And then a takeaway from this lesson and for the unit, a year from now, if I come back and I ask you, what are some ways on how to solve a system of linear equations? Then you need to be able to tell me systems of linear equations can be used to model problems, and systems of linear equations can be solved by graphing. What other methods? Substitution or elimination. Which one did we just use right now? Elimination, right? Okay, good. Okay. The lesson objective. Students are going to be able to make connections between various representations of a situation. Okay? You're also going to be provided with opportunities to apply what you have learned. Okay? And we're going to use a real-world content scenario to gain understanding of slope and y-intercept. Okay?
All right, so today we're doing who finishes when. All right, so take about 30 seconds or 15 seconds to read this on your own, then I'll read it with you. All right, it says, Ella's walking rate is 2.5 meters per second. Her younger brother, Mark, walks 1 meter per second. Because Alice's rate is faster than Mark's, Alice gives Mark a 45-meter head start in a 100-meter race. Okay, so our goal today will be what happens in the race. Okay, so we're going to give you a paper that has this prompt again, and you're going to work on it individually for about 5 minutes. So what are your thoughts, what's going on, whatever you're thinking, how to solve this problem. Okay, do you want to know who wins, who loses, who ties, whatever you're thinking, right? Start solving it. Then I'm going to have you share with the person next to you. And then eventually we're going to come in as a group and you're going to work together to show 4 representations. So here's going to be the 4 representations. We want a table, an equation, a graph, and a picture. Okay, of how to solve this problem. Got it? Alright, so let's go back to the prompt. We're going to give you about 5 minutes. Mr. Yuki, start the timer. Dominic, can you pass this on the side for me, please? So work on it individually. Get your own thoughts going before you work with someone.
Ladies and gentlemen, in 30 seconds, we're going to ask every other table to share their thoughts on what you've been reading right now. We're going to start with this table over here.
Well, I think that they're trying to figure out where Alice's brother is, like, where he could either like tie the race or be far, like, who's faster and who's slower.
We're wondering about what kind of start Mark needs to get to win.
So, we cut it in half. You decide which 2 does which 2. Got it? So remember, we need table, graphs, equation, and pictures. If you guys all want to work together, that's fine.
But it could be either way.
I think she has to. I think I have to do table. Then she has to do the equation.
Well, like Alice gives Mark a 45-meter head start.
That's what I'm working. And then this is the finish.
So this is 100 meters.
So like, where's your pencil, Lucy?
Okay, so how can you figure how many meters she's covered in 10 seconds?
Multiply the figure by 10.
It's 30,75. Should we do a try?
1, 2, 3, 5.
This shows us
That's where the lines are gonna intersect.
This is where they meet. This is where they're running into they made each other, right? They were tied, right? So that means
Before we end the period, we want to find out what you discovered so far. I know we're not finished yet. We will finish, but let's just give this period closure by sharing what you've discovered. Okay? So we're going to go and we're going to have tables share out what they've discovered so far. Is everyone okay with that?
Yeah. Yes.
Take about 30 seconds or a minute. Talk to your table what you want to share, so you know what's ready to go.
Well, we use y equals mx plus b to try to solve like their constant rate, and we came up with y equals 1x plus 45 because we know that Mark has a head start of 45 meters, and then for Alice we just put 2.5x equals 100, so we would find out how much she would run 100 meters.
Perfect. Beautiful.
Gentlemen.
Alice made the 100 meters, and Mark is 85 meters.
Ooh, nice.
Okay, so we found out that Alice wins in the end, and she and she beats him by 15 meters, and they meet at 75 meters.
Okay, perfect. Thank you.
Okay, ladies and gentlemen, leave your things on your tables. Leave them on your tables, and you're free to go. Thank you very much.